Sehr geehrte Damen und Herren, today I am going to talk about the third method of um, 3D vectors. I want to show you how to solve like these problems. I have a problem and we must know two equations. The vector FAB equal to magnitude of the F cross lambda hat AB, and we can lambda at AB find with the AB vector divided by the magnitude of the AB vector. So I can start with the question. Here a container of weight V is suspended from ring A. We are interested in about A. Cable BAC pass stroke ring and is attached to fixed supports B and C. So we can show the points. Two forces P is equal to Pi and Q is equal to Qk are applied to the ring to maintain the container in the position shown. Here we can see that there is a P vector in the x-axis and there is a Q vector in the z-axis. Okay, knowing that W is equal to 376 Newton, determine the P and Q. Okay, the tension is the same in both portions of cable BAC. Okay, we must first of all determine the BA vector and CA vector. If we see the distances, we must use the lambda hat method because the methods which we used in the first lecture, we don't need them, and they are not necessary to solve this problem. So we must use the method of lambda hat, and I'll show you that how we can find them. Okay. First of all, we call BA vectors T1 and the other ones T2. T1 from A to B, so I can write T1A B. You must be carefully because if something in here there's a mistake, you can do mistakes all of the questions. So you must be carefully. And from A to B, so there's the magnitude of the T1 cross lambda AB. Okay. We don't know the tension one, but we know the weight here. Point A. Here 376 Newton in a negative y. So we must find actually T1s in the x component, so we can find P vector while Uh, that's why that if we T1's x component finding, it is possible to say that the magnitude of the P1. So, mm, okay, I can continue. T1 lambda hat AB. How can we find that? There's a point B. I must determine the coordinates. So, for example, there is the point uh, under the x-axis 160 millimeter. So I can change them meter. Okay, and under the x-axis B, I write the point of the B. In the x-axis, it is we can see that 0.13, but it is negative because x-axis positive here. Okay, and I continue about the y. It is 0 because in the vertical side B has now a distance from the origin, so it's 0, and the z-axis we can see that 0, 16. Okay, we can determine the sign. It is uh, z direction, so uh, we don't need to minus. We can determine b. Okay, it isn't so hard, but uh, when I when I narrate you, it is something uh, hard. So I it is the point A. It has no components in the x-axis and z-axis, so we can write just y-axis. It's about here we can see that 0.4, but actually I wrong. Okay, okay. We can write like this. So from A to B, because we must B minus A. You must understand uh, the equations here. And okay, I do the calculation 0.16 and 0.4 and minus 13. It is T1 vector. Okay, so we must determine the distance AB, and we can see the formula. So it's easy to solve the problem, but we must determine the distance. How can we find them? For instance, uh, we can okay. We can create a triangle, and we must the triangles hypotenuse determining, and here 0, 16, here 0, 13, and we can find the first hypotenuse, and we know that here, sorry, here 0, 4 meters. So we know this, and we can find the distance from A to B, and I can write T1 distance. Point 16 square plus 0.13 square, and 0.4 square root. Sorry. And we know the tension one's distance, and we know tension one's the components IJK, I, J, K forms, and it is easy to find lambda AB hat. Okay. And square root I write the same things, and okay, we found the lambda AB. Okay, and here it's finished. So P is in the x-axis, positive x-axis, so P is equal to minus T1's x component, and minus T2's x components. So we must determine the T2. Okay, T2 is equal to the magnitude of the T2 cross lambda A from C and it's the equation, so I can continue with lambda AC is equal to T2, the vector T2, divided by the magnitude of T2, the distance, it's a distance. So, okay, we can start. point C. What are you thinking about that? The point C is above from x-axis. About what? About uh 0.15 meters, and about y-axis is 0, and the z-axis is minus 0.24. Okay, and a is the same, 0 minus 0 for 0, and I I did the same thing, so 0.x, comma 0.4 and 0.24. Okay, it is I hat, sorry, it's I hat, it is J hat, it is J hat. Also, okay, können wir continue. Lambda hat AC is equal to T2, the vector of T2 divided by it is T2 divided by IJK form, I plus 0.4J minus 0.24 K hat divided by the distance. What is the distance? We must determine the distance. AC is equal to here I can create a triangle, and we have no distance about y, so it is 0.4 square plus 0.24 square root, and it is a distance. I can explain that. This is our triangles, the left side and the right side. We have no direction about y, so with the equations we can find the distance. I write the distance 0.4 square plus 0.24 square root. We found lambda AC hat. Oh, okay. And the first equations we need to F AC is equal to lambda AC hat cross F magnitude. We say about T2 magnitude. And how can we decide to determine P? we can mm, we can try to uh, determine the x-axis, uh, magnitude of the x-axis. For example, here we can get in the x-axis 0, 15 I hat is divided by plus 0, 24 square root. Here is the T2s in the x-axis. Also, we found T1s, T1 here. We found T1's distance. Sorry, we must cross about the magnitude of T2, and what can we get here in the x-axis? 0, 13 I hat is divided by square root 0, 16 square plus 0, 13 square plus 0, 4 square root. It is also x-axis cross the magnitude of the T1. Okay, and okay. Also, we can determine the y-axis, and because of the knowing the width of the cylinder, we can find the T1 and T2, and later we can do this, but there is not problem. Okay, T1, there is T1s in the x-axis, so T2 in the x-axis plus T1 in the x-axis minus is equal to P. Es ist the wichtigsten solution, and it's very important to understand the question. So, in the y-axis, we can see after that the y-axis 0, 4 j hat is divided by square root 0, 4 square plus 0, 24 square root cross magnitude of the T2. It is T2 in the y-axis. So we must do again for the T1. T1 here, the J form, and 0 for J hat, and is divided by square root 0 square plus 0 for square root cross T1, and it is also T1 in the y-axis. So we can find T1 and T2 because of the knowing width. Width is equal to 376 Newton. So to sum up T2y and T1y is equal to 376. So we will have an equation that T1 and T2. So also we missed that the tension is the tension is the same in both portions of cable BAC. So the magnitude of T2 and the magnitude of T1 is equal. So we can call them T. So T cross 0 for J heads plus square plus the right of the equation 0 for J heads cross T is divided by square root 0 16 square plus 0 13 square plus 0 for square root. The equations is equal to width of the cylinder, and we can find T, the magnitude of the T. So we can find Q and P easily finding. How can we find them? It is simple because we have the equation here and we know T, so we know actually the equations, the number of the equations and this. So we know T2x, T1x, and we can find the P vectors, the magnitude of the P. So on the other hand, after finding P, we can find Q with investigating the z-axis. How can be possible that in the z-axis we have the equations here, and k hat is divided by the distance. So again, we can write T1, T, because of T1 and T2 is equal each other. So T cross here it is T1 in the z-axis, and it is T1 in the x-axis, nein, und das ist schlimm. Okay. Okay, here is the z-axis. It is the T2 in the z-axis, When we sum up the twice of the equations, we can determine the Q. It is Q, and we find the Z. We find the components of the T1 and T2s in the Z-axis, so we can find Q. We also found P, and the question wanted us to determine Q and P, so our question is finished. So we determine P and Q, and actually I cannot add more. It's enough to understand the lambda hat methods. Must be careful that it is distance, it is vector, and it is also vector, and we have the other equations here. We can find lambda hat, and we can determine the lambda hat and write in the equations 1. So the question wanted us to find the magnitude of the tensions in the separated axis, and we determined the P and Q today. It is all. See you next time.